like I said, get you to some homework time. But feel free to use the book as a good reference guide for that. Also be very well versed with your calculators. It's very helpful to be versed in that usage of the calculators. Okay, so yesterday we were talking about symmetry. We had gotten to page 5, and we were talking about symmetry in the y-axis, x-axis, and the origin. And then there's the tests for symmetry, which we were talking about yesterday. If you remember, Tate, remember the test for symmetry? We just started talking about it.
F negative x equals x cubed.
It's that you just threw out some terms that we did reference yesterday, which I'm impressed with. If our function is y equals x squared,
Yes.
okay, and then if we were to plug in a y of negative x into that, now that's a function notation you haven't probably seen a whole lot of, but you can just say y of negative 1, which means you're plugging in a negative 1 for x. It's the same thing as like f of x, but you just keep the y in there. So what you're stating is plug in a negative x for x, and so you'd say a negative x for x, and we know that a negative x squared is just x squared. So if you plug in a negative x into your function and an equivalent equation occurs, which it does, then it has symmetry
In the y-axis.
in the y-axis. And you also know that hopefully by the fact that you would know what this y equals x squared graph looks like without having to use a graphing calculator. Now, some of this is you might have to review it, but y equals x squared is your general parabola starting at the origin, opening up like that, and so therefore you can see the symmetry is in the y-axis. Now the symmetry test for the respect to the x-axis is, can you replace the y with a negative y and the same equation occurs? So if you were to take, again, we could look at this graph and say, well, no, it doesn't have symmetry in the x-axis. And we would know that by taking, if you plugged in a negative y equals x squared, is that the same thing as y equals x squared? Are those the same equation? The answer is no, because if you bring this negative could come over, but it's on the outside, and it's not getting squared, so it stays a negative. Therefore, this and this are not the same. So not symmetrical in the x-axis. So an equation, though, that would work, an easy equation, y squared is equal to x. If you were to plug in a negative y, does a similar equation occur? And if you simplify that out, sure, it does. And that is this equation here. If I told you to graph that, how would you graph that? You could do XYT chart. You could solve for y, right? If you solve for y is equal to plus or minus the square root of x, right? So then when you go to graph the square root function, this one's a good one to know. You start at the origin. If you're graphing the positive square root, it's all of those values up there. If you're graphing the negative square root, it's all the values down below, and it's a sideways parabola.
Seems like which fraction.
Yeah, so not a function. Why isn't this a function?
Because it goes through the vertical lines.
Yeah, it doesn't pass the vertical line test. Now individually, the upper is a function, the lower is a function, but together it's not a function because every x can only map to one y for a function. Okay. So, but that's how you could graph it, and sure enough, this has symmetry in the x-axis. And then symmetry in the origin is plug in a negative x and a negative y, and if a similar equation occurs, then you know you have symmetry in the origin. Okay. Points of intersection, we talked about how to find points of intersection. If you want to find an x-intercept on a graph. You plug in, if you want to find x-intercepts on a graph, plug in
Actually, y equals
0 for y, yep, and if you want to find y-intercepts on a graph, you plug in 0 for x and then
There's-
solve. Yep.
There's no, if the y equals 0 is x equals 0, then there's no, it's not a function, right?
If what? I'm sorry.
If there's no x-intercepts besides like the, if there's no 2 x-intercepts, it's not a function, right? Or imaginary.
Are you? Yeah, you could have a parabola like opening up, so no intercepts, but it's still a function, or no x-intercepts.
I was talking about that one's not a function because there's only one x-intercept, right?
Well, it's not a function because one x value here attaches to 2 y values, so it's not a function that way.
Okay.
If one input has 2 outputs, it's not a function.
So, if it's,
Then it's not a function. So you think about it, like, and it makes like, if you, if you, like, graphs that are functions, like if you have a distance equals rate times time, if you're traveling 60 miles an hour and you travel for 2 hours, you input 2 hours at 60 miles an hour, there's only one output. What's the output? You went how far? 120 miles. You couldn't have, well, I went 120 miles or I went 10 miles. Either one. And so there's certain, that's why in the rules of functions, now graphs can be non-functional, if you will, and there's still graphs that have that, but for it to be a function, every input can only have one output. But an output can actually have 2 inputs, depending on the graph. Okay, so let's go to page 8, and this is the way we do a lot of the homework, or not necessarily the homework, the lecture is talk a little bit about some of the basics, go over some of this, and then we get to problems, and then we just go like look at the homework problems, and then we can identify and say, hey, we're gonna look at number whatever 2 together. So then if you want to write down number 2, you can. If you just want to look at it, you can. That'll be kind of up to you. So if we go to look at this on page 8, it says match the equation with its graph. So actually let's take a look at number 1. So you should be starting to, or already at this point, be able to look at a graph and think what kind of equation in general it looks like. Or look at an equation and say, I know what kind of graph that's generally going to look like. Now, if I gave you if I gave you a y equals, 2x cubed plus 4x plus, 5 versus y equals 3x cubed plus 1/2 x squared minus 7, you may not look at that and say, oh yeah, I know the difference right away. But you should be able to look at these 2 equations and say, they are both, what's the leading degree? They're both cubic. And then based off of our work over the years of math, you should be able to think through and say, well, I know it's not that because that's a line, it's linear, right? I know it's not this because that's a quadratic, right? And so then you know it's not this because that's a sine graph, yeah, absolutely. Or cosine, but we usually call it a sine graph, like you think sinusoidal waves, seismic graphs on a earthquake. So usually we're referring to it as a sine graph, even though cosine is the same thing. But yeah, so you would generally like, okay, we know it's not this type of graph, because that's we just discussed the square root. It may get a little trickier because haven't worked with a ton of them, but you would know it's not that type of graph. Anybody know what that would be? That's a rational function, which we did cover last year, but that's where you get into like 1 over x or something, where you can't have x can't be something, x can't be 0, so there's a break in the graph. Sorry, that should have been red there. So just with a little bit of practice, you'll say, I know that a cubic is either going to look like this, that's if it's just x cubed and nothing else attached to it, or you're going to have something like this, right? And then, and you could start working on memorizing, does it open, if you will, up, then down, or does it open down, then up? Some of those details aren't that important, but just like you did, you just were able to reference all of these graphs. It just helps you speed up the mathematical process of being able to look at things and understand things. So if you look at number 1, what would 1 match to? B, because it's linear. And Tate, I'm just to track with you, I'm on page 8 now, referencing some questions.
Kind of read all of this stuff.
Oh yeah. Now some of it, Tate, as a good note taker, you have to distinguish, because what is important to write down. So I'm just kind of like, what would be the word? Chumming the mathematical waters.
Okay.
You know what chumming means?
No.
It's like when you're fishing and you just throw a bunch of like food over the edge of the boat to see if you can draw a fish up or a shark. I mean, I've never chummed water for sharks, but I chum the waters ice fishing. I'll throw a bunch of maggots in and hopes that like fish will be attracted. I don't know if that actually works ice fishing, but so you're I'm just throwing a bunch of stuff up there, not necessarily stuff you need. Okay, so page 8. If I could help you open your book to page 8, it's like causing me anxiety. Here, let me open it for you. I just want to help you. That is a crock holder.
Yeah.
Whoa.
Why open it?
I don't. I feel like it's gonna explode on me. I'm gonna help you out here. Page 8. Here we are. So number 1, Riley said match to B. This is a linear equation going to a number. Oh, class, please stand. We have a visitor. Can we say good afternoon, Mr. Hawkins?
Good afternoon, Mr. Hawkins.
Can we say it with a little more enthusiasm?
Good afternoon.
Good afternoon, Mr. Hawkins. Okay, you may be seated.
JV's at 5:30 versus
This looks like a tough class.
It is. Yeah, the smaller the numbers, the tougher the class. It's like,
So, is there another member in this?
Nick, but he's at football. So yeah, it's calc, which is awesome.
Is it starting off easy, hard?
Yeah, easy, yeah.
Okay.
Well, you know what's awesome is they know all the stuff on the board. They know, which looks complicated.
Good work.
But they know all of it. It's very encouraging, and it's encouraging. Riley's taking it because she said, "Why did you want to take it? Maybe not want to. Why did you feel you should take it?
So I wouldn't be lazy.
Be challenged. Is that awesome? So
What I want to hear from my seniors.
yeah, it's great.
Sometimes a lazy academic laziness.
Yeah,
That's good. You'll do well, sweet.
she will do well. Some tears will be involved.
Always.
Standard, always.
Always.
Yeah, it's good though. So, all right, see Mr. Hawkins. So number 1 we look at is there. Number 2 for the video, since I'm just orally doing this. Tate, number 2
Number
matches
two.
to what? Get this
D, because it's a square root, so.
Okay, it's B, the square root.
No, D.
Wait, D.
D.
D, yep. Now, that's a square root function with the x being squared. And so if you look at number 2, I'll write this up on the board here, is that if you were to go in reverse, if you will, and square both sides, let's check that out. Now you don't, like, this is one of those things that you don't have to know this, but for understanding, Tate, you just said that matched this picture here, right?
Yeah.
Which is what would look like what does that look like? A
Parabola, kind of.
well, my picture's not as good. Sorry, I shouldn't have.
Parabola.
No, not quite a parabola.
Rainbow.
No. Yes, a rainbow.
Circle.
Half of a circle, right? Looks like a semicircle. So, and do you remember the circle equation from geometry and a little bit of algebra too?
No.
Y minus Z.
Yeah, but anyway, throw in some
It's
variables.
I'm just gonna say
Oh,
variables. H minus
Minus H
H
squared.
minus H squared plus
X.
X. No, Y.
Y minus Z. K.
Okay. Squared equals
Equals R squared.
Yeah.
radius squared.
Now, H and K, whether you use different variables, but where H and K represent the what of the circle? Center. Yeah, nice. And then R would stand for your
Radius.
radius. So when you look at this is a semicircle. You look at this represents in half of the circle. Specifically, it represents the positive half, right? The upper half, because it's the positive on the square root. So if you went in reverse and you squared both sides, you would say, well, that's y squared is equal to 9 minus x squared. Bring the x squared over. X squared plus y squared is equal to 9. What that tells you is this is a circle with center 0, 0, because x minus 0, y minus 0, and then a radius not of 9, but a radius of 3. And then you look at your picture and you're like, oh yeah, it's the semicircle, so a radius of 3 at the center of 0, 0. Now, if you went in reverse and you subtracted the x squared over, and then you square rooted it, you would get plus or minus root 9 minus x squared. And the reason why you have both, well, because whenever you take the square root, you have to say plus or minus. And now you have the upper part of the circle, and then you have the lower part of the circle. That's the negative portion on there. So you have the upper and the lower. But in order for it to be a function, you would only look at half of it at a time for it to be a function. Okay, so then number 3 would match to the A, the parabola, and then 4 would match towards which one? C. Okay. Now we look at 5 through 14. I don't know exactly what numbers you had to do, 3 through 66 every third or something. So if we look at 5 through 14 to make sure we know how to do that, it says sketch the graph of each equation by point plotting. I'm okay if you don't want to plot points. What they're referring to though is just making XYT charts, plotting some points and seeing what the graph does. If you want, you can. I'm okay if you want to use Desmos or your calculator, but you should be able to understand what the general picture looks like, or on some of these, you really should be able to, like on number 7, like without a calculator, you should be able to graph that, even without even plotting points, you should be able to look at that and graph that.
It's a frowny face.
It's a parabola opening which way, up or down? Down. And then where does it cross the y-axis?
Quattro.
4, yeah. Like that, and then goes down like this, right? So you should be able to graph that type of thing just from knowing your previous usage of parabolas and work with it. Now, it says plot pointing. I'm not gonna, like on a test, I'm not gonna do this, put this one on a test. But that would simply mean you're like stating, I plug in -5, what do I get back out? I plug in -2, what do I get back out? 0, what do I get back out? 2, 5, you could plot some points that way. So that's what they're stating with that, but you don't need to. You should be, let's look at this one, like number 10. You don't have to do number 10, but I want to, like this type of equation is good for us to know. When you see the absolute value like this, what kind of graph is being formed? What does our graph look like? We haven't necessarily worked a ton with absolute values.
X has to be positive.
Is it the,
Well, X doesn't have to be positive because you can plug in a negative, but you'll output a positive for that.
is it the?
Y is.
Oh, that's a
Oh, no,
good,
no.
that's the integer function, the greatest integer function, which we will talk about at some point.
I know, it's like,
You're thinking this, right?
no, wait, Mr. Olson,
Or there is, okay.
Mr. Olson makes like this shape, and the lowest it goes is -1.
Could you do that for the camera? Because Nick can't see that.
Yo,
And all the other YouTube subscribers.
It does this thing, but like the what is it called? X-axis is here.
Too close to the-
Here, Riley,
Back up.
Riley, make the X-axis. So like, it's like that. All right, cool.
This is calculus. Yeah, it makes a V.
Yeah.
A V, yeah. So, the general. I'm gonna have to go back and watch this. It's great. So like y equals absolute value of x is gonna come down, right, and then bounce back up like that. When you have the -1 on the outside, that's going to shift your graph which way, up or down?
Down.
Shift it down, right? So again, they're saying plot pointing or point plotting, where you can plug in 0, output -1, plug in 1, output 0, plug in -1, output 0. Even better is if you can just do that, look at it and plot it without having to plug in points. When you get to like number 11, let's just keep going with some of these because it's good practice for us to know these. Number 11 is square root of x minus 6. So we've talked back here what the square root function looks like. The upper part, and then if it's negative on the outside, that's the lower part. So we look at this, we have a square root of a negative x, so the general look of that, right, would be starting at the origin, going out like that. That's the general square root function. What does the -6 do to it?
Bring it down.
Yeah, it just drops at 6 units. So you go down 6 units and then it goes out like that. So when will this one cross the x-axis?
No, never, but it will touch it at the origin.
When will this graph cross when will it cross the y-axis? I'm sorry, the x-axis. When is it going to cross? It will cross the x-axis.
At x equals 36.
Yeah, 36. You bet. Nice. Okay. 13. If you look at number 13, this is what we call anybody know what kind of equation or function we call this? We kind of reference it over here what the general look might look like. Over.
Down.
It's
Yeah, like this one, yeah. Anybody know what we call these types of functions? Starts with an R.
rational.
Yeah, rational function. Nice, because it's a fraction with the variable in the numerator, denominator. Yeah, because if you have y equals x over 3, what kind of graph is that?
A linear.
Yeah, linear, absolutely. What's the slope? 1/3, yeah, nice. So it looks a little confusing because it's not the format that we're used to, but that's just linear. This is non-linear because you have the x in the bottom. So with this one, you could plot some points, but what point do you know x can't be? What's the domain restriction on it?
0.
Yeah, x can't be 0, so here we go, we got a red marker. So you know this is going to be a vertical asymptote. If you remember doing these in, I don't know what chapter it was, 19-2 or something, we did some of these. So you know it can't be there. Now let's just, you might not know exactly what it looks like, but let's do some point plotting, just mentally. If you plug in a -3, what are you going to get out? If you get in a -3, you're going to get out a -1. Now extrapolate that out. If you put in like a -100,
Whoa.
3 divided by negative 100, you're still going to get out a negative, but it's going to be really what? Small. So as you go farther out here, right, your values are really small. So then it's coming in this direction. And then when you plug in a negative 1, you get out a negative 3. And then when you think about it, okay, if you plug in like a negative 0.1, 3 divided by a negative 0.1, 0.1 is the same thing as 1/10, so it's 3 divided by a negative 1/10. When you divide by a fraction, you flip and multiply, so it's actually going to be like a negative 30. So the smaller the value you're plugging in, like a negative 0.1, well, I'm going to say larger, it's a larger negative, so it goes like that. So then on the other side, we just have to figure out which quadrant are we going to be in. Are we going to be in 1 or 4?
Uno.
Uno, because you're plugging in positives, your outputs are all going to be positive, and it looks like that. Okay? Very good. 15 and 16 use a graphing utility. That's the same thing as a graphing calculator, or you can go to Desmos, but a graphing utility. Graph the equation, move the cursor along the curve to approximate the unknown coordinates of each solution. Obviously, you could just plug in, like on 15a, it's the square root of 5 minus x, right? Is that your function, square root of 5 minus x, and they're saying 2 comma y for part A. So you could just plug in 2 and then say, oh, it's the square root of 3, which is 1.73. But that's not the goal, right? The goal is make sure you can plug that into your calculator and then be able to plug in 2 for x and get out an output for y. Just make sure you're comfortable with your calculator.
Square root of
Graphing. Yeah. But it should give you a decimal, so make sure you're comfortable with your graphing. They actually want you to move the cursor like in a trace function, but that's not, that part isn't too important. Okay.
unnecessary.
That is unnecessary. Okay, 17 through 26, it says find any intercepts. So if we were to look at number 20, and number 20 states, what does it state for us? Y squared is equal to x cubed minus 4x. Is it 4x or 4x squared? What is it? Y cubed, or y squared equals x cubed minus 4x. Yep. So on that one it says state any intercepts. Now we have talked about zeros. What are zeros referring to? I think Nick brought up this. The x-intercepts, right? Zeros, answers, solutions, roots, those are all referring to x-intercepts. But if it says find the intercepts, it's not just the x-intercepts. What's the other intercept it's referring to?
Y.
Y-intercept, yeah. Now, when you look at a graph like that, you might be like, I don't know, does it have any x-intercepts, any y-intercepts? Well, the way we have to do it algebraically is, if I want to find, let's start with x-intercepts. What do I do if I want to find my x-intercepts? 0 for y, okay? So the expectation on a problem like this is show algebraically how you do it. So how do I find algebraically? Nice, yeah, factor.
Factor.
Yep. And so we factor it, and then what are my x-intercepts going to be?
0, -2.
Yep. So 0 and then plus or minus 2. Very good. So there's your x-intercepts, and then to find your y-intercepts, what do? Plug in 0 for x. So your y-intercept is just going to be 0 for that. Okay? So that's what you would do on those. Most of those should be, or all of them should be algebraically possible. If not, either we we can work, if you get to one, you're like, I don't think it's algebraically possible, we can take a look at it and make sure that that's the case. Now, when we go over to 27 through 38, it says test for symmetry with respect to the axis and the origin. So if you look at something like, let's say 32, x y squared equals negative 10 on 32. We're about done here. So on 32, it's x y squared equals negative 10. So to test for symmetry in the y-axis, what do we do? Plug in a negative for x. If you ever forget, you can think y equals x squared is this graph. It's symmetrical in the y-axis. If I plug in a negative x, it's the same thing. So that's testing symmetry in the y-axis is plugging a negative for x. So we say, okay, y-axis, negative for x. Do I get out the same equation? Are those the same? No, because the negative is here, we don't get rid of it, right? So not symmetrical in the y-axis. The x-axis, what do we plug in for?
Negative one.
Yep, so x would stay the same. Now when you plug in a negative y, what's a negative y squared give you? Yeah, it's just y squared. So is it symmetrical in the x-axis?
Yes.
Yes, and the origin, what's the origin going to be? Negative x and negative y. So you end up with a negative x y squared. Parentheses on there. Therefore, is it the same? No, because it's now got a negative x that didn't go away, which isn't the same. So no, not symmetrical there.
In the origin.
Yeah, over the origin.
Okay.
That one seems a lot more complex than the other.
It's a little bit more. Okay, so work on the homework. This isn't due Tuesday. I'll probably do Thursday most likely. But you should, if you want to get started on it, you can do quite a bit of it. And then we'll make sure graphing calculator's here on Tuesday because we need to do a regression lines, plotting linear regressions or quadratic regressions or whatever. Okay?
Thank you.
Riley, thanks for joining.